Steam Generator Boiler, Part 2. In this video you can understand about boiler draft and air and gas system in the boiler. If you like this video, plus subscribe my channel, show views and like it. Boiler draft. The difference between atmospheric pressure and the pressure existing in the furnace or flue gas passage of a boiler is termed as draft. Draft can also be referred to the difference in pressure in the combustion chamber area which results in the motion of the flue gases and the air flow. Types of draft. Drafts are produced by the rising of the combustion gases in the stack or by mechanical means, for example a blower, and can be put into four categories: natural, induced, balanced, and forced. Natural draft. When air or flue gases flow due to the difference in the density and acted upon by the force of gravity in stacks is a natural draft system. Simply put, the difference between the density between the hot flue gases and the cold gases in the surroundings results in a natural draft at the stack entrance. Forced draft. When air or flue gases are maintained above atmospheric pressure. Normally it is done with the help of a forced draft fan. Induced draft. When air or flue gases flow under the effect of a gradually decreasing pressure below atmospheric pressure. In this case the system is said to operate under induced draft. In this case, the stack's chimneys provide sufficient natural draft to meet the low draft loss needs. On the other hand, in order to meet higher pressure differentials, the stacks are operating with draft fans simultaneously. When the static pressure is equal to the atmospheric pressure, the system is referred to as the balanced draft. Draft is said to be zero in this system. Balanced draft. When the static pressure is equal to the atmospheric pressure, the system is referred to as the balanced draft. Draft is said to be zero in this system. Air and flue gas system. The air and gas systems are provided for forced draft to the boiler for complete combustion of the fuel. The gas recirculation fan increases the mass flow of air to maintain the hot reheat temperature. The flue gases going to the stack raise the inlet air temperature, ultimately increasing boiler efficiency. Boiler drains and vents system. The water that is fed to the boiler contains impurities in the form of suspended solids and dissolved solids. A large portion of these impurities is left behind when the steam leaves the boiler. Some of these suspended impurities have tendency to settle down in the lowest part of the boiler. Others are light and float on the surface of the water. The operator must control the buildup of impurities by injection of chemical into the feed water and blowing down. Blowing down at a slower rate and over a longer period of time reduces the concentration more effectively than is possible by opening wide the main blowdown valve. Therefore, closer control and more accurate regulation of the blowdown is achieved. The continuous blowdown requires the use of the blowdown flash tank, where the high-pressure water can be flashed into low-pressure steam. Vents are provided on different pressure parts of the boiler. They are used during depressurizing, filling, and charging the system. All drains and vents are manually operated and are used during startup and shutdown. The purpose of this system is to vent and drain the superheater, reheater, boiler drum, economizer, aerator, and boiler convection pass during startup and shutdown activities of the boiler as required. To cool down the high temperature drains in the blowdown tank before sending the water to the wastewater system. Use of drains. Superheater drains. During startup, these drain valves are open to drain any buildup of water in the superheater. Water remaining in the superheater would restrict the flow of steam and cause the tubes to overheat. In addition, operating with the superheater drains cracked open allows steam to circulate through the superheater tubes, thus preventing excessive heat buildup. During shutdown, these drain valves are usually open to depressurize the superheaters. Reheater drains. These drains are usually open for depressurizing the reheaters during shutdown. Drum level gauge drain. This drain is usually opened when the gauge glass is required to place in service. Economizer inlet drain. These drains are used for draining the boiler after shutdown. Lower convection pass header drain. These drains are used for draining the boiler after shutdown. Downcomer header drains. These drains are used for draining the boiler after shutdown or cycling the feed water system during normal operation. Continuous blowdown. This arrangement is used to remove the silica and other impurities from the steam drum water. Drum vent. During depressurizing the boiler, open the vent at 2 kilograms pressure. Keep this vent open during the following situations: boiler filling, until steam pressure increased to greater than 1.5 kilograms to prevent a rapid increase of drum pressure during startup. Superheater vents. Keep these vents open until steam comes out of those during startup. This was part 2E. That part covered the boiler drain and vent system. Next is part 2F, boiler accessories. Please keep watching Shoaib Views channel for technical and informative videos. If you like video, please like, subscribe and follow my channel.